This new year was dominated by extraordinary news from the New Horizons mission. The New Horizons mission was something on everybody's radar in July of 2015 because it went past Pluto, snapped this beautiful image, and in fact, here's this incredible footage no one knew existed of the visit of New Horizons when it went to see Pluto. And Pluto was very, very happy to see us. But New Horizons did not go in orbit. It just flew on by. And so I wish I knew who to credit for that. So we're going to have to find out. It was a tweet from 3 years ago. But anyway, that's because it's continuing its voyage of exploration. And you can see in this little diagram, the little red arrow out there to the left, New Horizons going to visit something called MU69. And here's its Kuiper Belt Extended mission. It's going out to visit this object out in something called the Kuiper Belt. And we're going to tell you all about the Kuiper Belt. How many of you have never heard of the Kuiper Belt? And in this room, there is no shame. So you've proudly, I've never heard of it. Great. So we're going to tell you a little bit about it. It's a part of the solar system that really has not yet been explored. And this is a real breakthrough. New Horizons is really taking us into the Kuiper Belt. This object was first detected, that's a little space telescope, Hubble Space Telescope detection of, and you can tell because on successive periods of time, days later, the object had moved. And so we were able to find this object, this very tiny object in the outer solar system. Now, we were able to get a little bit of a handle on it by doing what are called occultation studies. And an occultation study is when the object, this MU69, passed in front of a star, and the star blinks out and then blinks back on. So there's the star, it blinks out and blinks back on. I hope you all saw it blink out. Everyone see that? Yeah. So if you do that with a bunch of people at different locations, they see and can trace what time precisely it blinked out and blinked on. And when you draw a line for each and every one of those people as the thing is moving across the sky, you can see where it blinked out. That's those things in the circle. So we already knew that it was probably either bilobed or two separate objects. So the artwork that was done before the mission showed it as either two objects or maybe this kind of duck-shaped, bowling pin-shaped, what's referred to as bilobed object. So we knew we were going to pass it on New Year's Eve and get pictures back on New Year's Day, and that's exactly what happened. So here in August, we were able to acquire the object. The little spacecraft saw it, and then just 2 days before, really a day before, we had this amazing image of MU69. Now, I should say that MU69 was given the nickname Ultima Thule, which if you've been here at the show before, I always love to say Ultima, like multipass. But anyway, other shows, people don't get that joke. Thank you. Okay, I really appreciate it. Anyway, you know, that's the image that they took, and there was, you know, in the press conference, like, oh my God, I never saw so many excitements over 6 pixels. And John Spencer said, but we've had only one for so long. So it was very, very exciting. And then they did a bunch of image processing and tried to figure out what would give that kind of signal that they could sample, and came up with that smudge on the right. Of course, Twitter said, a fellow on Twitter did a reconstruction, said this is what Ultima Thule looks like. Someone said it's a Minecraft version. I don't play Minecraft, but I think that's funny to some people. So here it is, and we also saw that it was rotating. Now this was particularly cool because as we were coming up to it, there was no variation in the light curve, meaning it stayed the same brightness. And usually if you have a tumbling object and it's big on one side and small on the other, you'd expect it to get brighter, dimmer, brighter, dimmer. It wasn't. It was completely staying the same. And people were like, how could that be? Well, as you can see from this rotation, we're sort of looking at it spot on. We're seeing the same sides as it really just kind of spins in our direction. Does that make sense? So we had the flyby. So we're going to show you at 7 o'clock in the morning. How many of you were up? Yeah, some of you, yeah, definitely. To tune in and watch this.
Go ahead, RF.
Well, the green screens will tell you, and RF is in fantastic shape.
RF is radio, so
RF
communications. That's so sweet. She's whispering.
Copy, thermal is reporting green status.
So now you hear a bunch of different things. Thermal, navigation.
Mom, planning.
Go ahead, planning.
Pointing and control.
Planning is good.
Copy, planning is nominal.
Mom, FC on Pluto 1.
Go ahead, FC.
FC is green, and DSN has provided fantastic support as always.
Copy.
DSN, Deep Space
Go
Network.
ahead, GNC.
GNC looks good.
Copy, GNC is good.
All right, so that's got.
Go ahead, prop.
Propulsion is green.
Copy, prop is green.
Mom, power.
Go ahead, power.
Power is green.
So a healthy
Copy, power
spacecraft.
green.
But did it get any data?
Go ahead, CNDH.
CNDH is nominal. Our SSR pointers are right where we predicted, so it looks like
The big cheer is the SSR pointers mean we've got a full computer of data, whole hard drive of data.
CNDH is green, and we have a good data record of Ultima Thule science. Go ahead, autonomy.
Autonomy is nominal.
Copy, autonomy is nominal.
we're going to take time to make sure
MSC, SSE.
System engineer to mom. Status is green.
Copy that, green. Any more status to report?
Go ahead.
We have a healthy spacecraft. We've just accomplished the most distant flyby. We are ready for Ultima Thule science transmission at 200 UTC today. Science to help us understand the origins of our solar system.
That's it.
So that woman, they did call her Mom. That stands for Mission Operations Manager. She was kind of the mission chief. This fellow, Alan Stern, is the science lead, the principal investigator, the head of the whole mission, really. And so many of you probably saw him. So yeah, Alan Stern on the left, Mom on the right. And here is what Alan said at the press conference shortly thereafter.
Best image of Ultima Thule, made by New Horizons at a range of about 500,000 kilometers out. Well, that image is so 2018. Meet Ultima Thule.
So that is our little baby. And there's so many things you can see about it right away. There's a ton of science. You may think, but it's just a rock. There are amazing things we've already learned just from that. But before we get to the science, what does it look like to you? Exactly. How did I know? I put it in the power pen. It looks just like a snowman. And of course, the other big lead is BB-8. It does look like BB-8. And of course, just as we said, here was, remember I told you about the occultation study that predicted it was like this. And in fact, this is Ultima Thule filling that. Beautiful fit. And what this does is verify that the occultation studies are really, really powerful tool. Because we have an in situ measurement to verify a blinky star, so that's wonderful. They took color images. It's red, like a lot of outer solar system objects are. Could be organics that have been processed, which is interesting in and of itself because it's so cold and distant from the sun out there. And so, as you can see in this little picture, it's just saying that most everything on this object is redder than some of the stuff. We're going to come back to this later. Orbital tilt, you'll see there are different populations. We're going to come back to it. Not only is the color different, but there are differences in brightness, and this is quite interesting. You've got very bright spots, you've got dark spots. There might be some streaks on there that they've sort of seen. But the key thing is that they were flying straight on it with the sun behind them, so they didn't have a lot of relief. There wasn't a lot of shadow. But as they flew past it and continue to fly past it, you'll get the shadows will become longer and you can actually see the relief on it. So from an image like this, it's really hard to tell whether there are craters or not craters because you're not getting the depth perception if you don't have the shadows telling you what the different things are. So there it is now in its rotation. You can see, yep, it's rotating just like we thought. That's the rotation axis. So it's like these two things are just rotating around a common center right through the biggest one. And that probably stems and fits right into our picture of how we think this thing formed. They released, the team released this lovely picture showing the formation in the very early parts of our solar system when the outer solar system was just gas and dust and stuff was kind of swirling around. And so gravity caused things to stick together and aggregate. And eventually got down to two of them and then slowly they spiraled into each other and kissed, just lightly touched each other. And that narrow, narrow neck is quite fragile, but in fact, the rotation rate is not high enough to pull the thing apart. It is thought to be the way most of these kinds of objects are in fact formed. And when you look around the solar system at a lot of comets that have fallen into the solar system, you'll see that a lot of them have that bilobed structure. So I failed to say at the very beginning that the comets that fall into the solar system, you know, we see as comets in the sky, many of them, a great number of them, come from this region called the Kuiper Belt, and we're going to come back to that. Here's an artist who works for the project who made a little sculpture of it. And again, I just want to point out how delicate and thin the neck is of that. And the neck is bright. So it has that extra material there. And you know, there's, as I say, there is science involved in that. The team also looked for moons because they wanted to see if there was any leftover from that whole spirally thing. And most importantly, because moons would tell you what the mass is. We know the size of it, we don't know the total mass, so we can't figure out the density. Whether it's a fluffy snowball or densely packed ice ball or what it is, we really don't know. So I had the opportunity to speak to someone today and congratulate him. So we'll show you a few bits.
You must be exhausted. Look at your room. Have you had any sleep?
I don't visit here very much the last week. For the final approach and then the initial days where we were doing all the public-facing events as well as analyzing data literally till 3 and 4 in the morning, it was cat naps. It was 3.5 hours of sleep each night.
So he looked a little tired there, don't you think? His eyelids were drooping.
Who is that, Laura?
Oh, who is that? That is the principal investor, Alligator Stern. Can't believe I did that. Don't tell him. Yes, the principal investigator, Alan Stern. I like Alligator Stern. I think that's a good name for him. So, you know, so he was the one who came out with a high five and the hug. He's the principal investigator, and he's a friend of the show. He's been here before and been to Griffith Observatory, and he promised to come back. So we have a couple of questions and answers just because he couldn't be here in person. In fact, you'll see later I say the reason he couldn't be here live, which he wanted to do, is because they're having their party right now. So he couldn't miss they're all on the East Coast. It's 3 hours later. It's 10:30 his time. So he's in the middle of a party, but he took out some time to talk to us. So what was it like on New Year's Eve and New Year's morning? Can you just kind of walk us through it?
Well, the spacecraft was operating off on its own and not spending any time communicating back with the Earth. Back on Earth, we had a full day of programming for NASA television and for the 1,500 guests that were here. Used it as a teaching moment to talk about the Kuiper Belt, the Pluto system, what we expect to get out of the Ultima Thule flyby, and many other things. We made an opportunity for the whole day to stress to do public outreach for children. And at midnight, at 12:33 in the morning, I had a couple dozen kids come up on stage with me and do the countdown together. And some of them were in space costumes and holding New Horizons models and everything. And at the moment of closest approach, all this confetti went off all over all of us. And that picture ended up on the front page of the New York Times above the fold on January 2nd.
That's great. So he actually has been hard at work, and I loved this little part while we were talking. But I do want to ask two quick questions.
You know what I was doing while I waited for your call?
What?
I was writing the first scientific paper.
What's the title, or what's the subject? It's
Due to Science. Initial results from the reconnaissance flyby of Kuiper Belt Planetesimal 2014 MU69.
That's wonderful. And we'll see it in Science submitted next week?
No, not until February, because we want to wait for a lot more data to get to the ground.
Gotcha.
And pack it with a lot more results.
Yeah. So in fact, this is a key thing about it. The mission, the spacecraft and Ultima Thule are now behind the sun. So you can't, there's nothing to be done. We can't get any radio back from it, we can't get any information. We have to wait until it comes out from the other side of the sun. So they get, blessedly, after only getting 3 hours of sleep at a time, they get a week and a half off. And that's why you're saying we're waiting for February because, well, the first data start coming back on January 10th. But in February, we'll get the closest flyby images. And the ones that we saw, you know, the best one that you saw, our BB-8 shot, is about 45, let's see, what am I trying to say? It's about 20,000 pixels. The one that we will get in the close flyby is going to be about a megapixel. So we went from 6 pixels to 20,000 pixels to 1 million pixels across Ultima Thule. So we're going to get some really, really high resolution data, and that comes down in February. You're not able to do this live tonight because you're headed to a party, correct?
Yeah, the team celebration is upstairs in this hotel, 5 floors above me. It's already started, and I just started about the time we started the interview, and I'm going to go up there in a little bit.
That's great. And is everybody just over the moon, just excited beyond belief?
Yeah, it's incredible. It's the same feeling we had at Pluto. This was a much tougher flyby, and the spacecraft and the sequence that we gave it performed perfectly. And we know that the solid-state recorders, the flash drive memories on board are full, and the data that we've got to the ground is just priceless. We've got less than 1% of the data, and already we've made big discoveries, so we're really happy.
So the last question, and we'll let you get to the party, is what are you most looking forward to in terms of discovery?
The target is so amazing in the data that we have, and there are these strong albedo variations that you don't typically see on asteroids or on comets, for example. And then the other thing that I'm really interested in finding are what will we find that we're completely not expecting?
Yeah.
So we'll see. It's all about discovery.
And I think we have one more. 2 quick questions on the science. One is, did you find anything about the composition? I know there was a lot of talk about the composition team getting data, and then I didn't see anything in the following, really anything new in the following conference. Is there anything you can share about the composition that you found? So this
Absolutely.
hasn't been out.
Our composition spectrometer produces hundreds of wavelengths. Which we make a graph of the reflectance spectrum, and from the absorption lines in it, we determine what species are on the surface and how much of each. What we sent home was a very sparse set of slices, only 27 wavelengths out of all that. And we used it only to produce an infrared color slope, not an actual composition or composition map. What we can say is that the water bands, if they're there on the surface, are much less distinct than on the satellites of Pluto, which are similarly sized, and more reminiscent probably of the kind of very weak water bands that you see on comets, which of course themselves come from the Kuiper Belt.
So again, you've heard it here first. Truly, that hasn't been out there. So in any of the press releases or press conferences or anywhere else, so I thought, oh, good, we got a scoop. Yay for us. I want to say from the bottom of my heart, Alan, I'm so proud of you. I guess that's a weird thing to say to someone, but I'm so proud of your team and so proud for this country. And I know you have been, your patriotism has been something that people have even commented on, but I want to thank you for that and for your
Thank you. You know, we're big on things like flags in our imagery because we know who paid for it. We give the data in NASA, we give the data to all the world. The scientific publications are available to everybody, but it's the people of the United States who made this possible through their tax dollars. And, you know, they should be recognized for that.
Well, you've obviously been an amazing leader to the team. It's clear how cohesive and excited the team is, and I just want to say thank you and congratulations again.
Thank you, Laura. Thanks for the invitation to be here.
So, Alan Stern, everyone. So, of course, and thank you for sitting through that, because I know it's different when he's not here in person, but that's history right there. So I'm glad I was able to grab that and share it with you. And of course, there's one other little piece of history. As Brian May was there and wrote a song and did his first solo performance, I think, since the late 90s. And at break, we're going to play his song. How many of you have heard it? So, New Horizons. You do a good New Horizons.
Yeah, like New Horizons.
There he goes. That's kind of what it sounds like. So before we go on, I have a message for you from Alan Stern. Are you ready for this?
Yeah, let's go for it.
You can just tell Constantine that if he's talking about Planet 9, he better be talking about Pluto. There is a real hashtag.